All right. Sections 10.2 and 10.3 are kind of like what we encountered in another section of material, and I can't remember which one it was. But sections 10.2 and 10.3 really are just one big giant section that they split. Okay. Oh, it wasn't in this class. It was a different class I was thinking of. Okay, so big giant section, they split it into two sections in sort of an arbitrary way. And it does feel kind of arbitrary. 10.2 ends up being lengthier, more in it than section 10.2, so 10.3. So it doesn't even like they split it evenly. But what we're going to be doing in both of these sections of data, or sections, is displaying data. And so we're going to be looking at different ways to create graphical representations of data. And not like XY ordered pair data, but other kind of data. So the first one we're going to see is one that you see children using very, very little. So those of you who are like, I want to teach with the biddies, you see this one. Okay, so the last time I saw this information presented like this was when my daughter was in like pre-K. All right, so real early stuff. So these are pictographs. So pictographs are picture graphs representing tallies in each category. And so I specifically remember her doing one with like jelly beans, right? Where they drew the jelly beans in and they colored them and they physically did jelly bean something in class, hands-on kind of something. So you can do really fun stuff with pictographs with the little ones. And so we're going to do one that's a little bit not so, like you wouldn't do it with little kids. But it still works for a pictograph. The Automobile Club of America considers holiday weekends to start at Friday at 6 p.m. and last until Monday at 6 p.m. If 150 people died on such a weekend, this is why you're not going to use it with the little kids. They're talking about people dying. It's not a good plan, okay? 150 people died on such a weekend from 6 p.m. Friday to 6 p.m. Saturday, and then 80 people from Saturday into Sunday, and then 100 people from Sunday into Monday. We're going to draw a pictograph. So when you're using pictographs with little ones, one jelly bean drawn represents one jelly bean. But when you're dealing with bigger sets of information, you don't draw every single object, right? We're not going to draw 150 people. I mean, we could draw stick people, but we still don't want to draw 150 stick people, right? We want to draw something that we can actually represent several in one category. So what we're going to do is we're going to create first some lines. So we're going to create some lines. We need 3 different categories, so you're going to have 4 sets of lines, or 4 lines, excuse me. So that there's spaces between. There's 3 spaces, okay? One space is going to represent the Friday to Saturday, right? They're specified by times. If you want to put that in there, you can. Then this is Saturday to Sunday, and then we have our Sunday to Monday. Those are our 3 time slots. And the numbers we have are, let's see, it was 150, 80, and 100. We need something that's kind of large because whatever we pick, we're going to have to draw a bunch of objects. So in other words, I don't want to let whatever object I draw represent 2 because 150 divided by 2 means I still have to draw 75 objects. Right? I don't want to do that. That's not particularly helpful. I want it to represent a big quantity. So I'm going to suggest that we're going to let a heart represent 20 people. Why a heart? It's a little bit arbitrary, but there is some structure into why I chose a heart. I chose a heart because if I cut a heart in half, it doesn't look like the same object. Sometimes people want to draw like a square. Well, if you cut a square in half, especially if you don't draw super specific, it's going to look like a rectangle, which looks an awful lot like a square. Right? So we want to draw something that when we split it looks like it's been split. Sometimes you'll see people draw, and there's an example in your book where they draw circles. And then they draw a half a circle or a quarter of a circle. Circles work really well for this. If you did want to use a square, it'd be okay, but when you do, whoops, that was still a circle. When you do a square and you cut it in half, you'd want to draw like half of a square like this. Right? So think about how you're going to make this clear with what you're doing. I chose hearts. I chose 20 people because, well, 10 people would work, and you could totally do 10 people. It'd be okay. If I did 10 people, I'd have to draw 150 divided by 10. I'd have to draw 15 of my hearts. That wouldn't be too bad. We could do that. But I chose specifically 20 because I want to show you what happens when I split it. So that's actually why I chose it, not because it's really necessarily the best choice. So if I have 20 people represented by each heart, how many hearts do I need to represent 150 people? 7.5. I need 7.5 hearts. So as I'm drawing my hearts, they need to all be the same size, okay? So if you draw some hearts small and some hearts large and some hearts really big and some hearts really close together, it creates chaos, okay? We don't want to do that. We want all of our hearts to be as close as we can anyway to being the same size. And I have an unfair advantage because I can copy paste, and I get that. So mine are all going to be exactly the same size. That's 4, 6, 7, and then I'm actually going to paste the 8th one, and I'm going to erase the part that would make it the other half. And I'm going to split it in half like that. So it's very clearly half of a heart. So there's 7.5 hearts. How many people died between Saturday to Sunday? What was the number they gave us? 80. So how many hearts would I use to represent 80? 4. So I'm going to do 4 hearts here. And when I do the next line, they have to line up vertically, right? So my hearts have to be one right underneath another. 2, 3, and 4. So I'm not going to be like super over the top nitpicky, but it has to look reasonably like you've made a good effort to do so, okay? So make it look reasonable. And then the last one, 100 people from Sunday to Monday. How many hearts would that one be? 5. There's 3. And there's my 4, 5. All right, there are some features that every graph needs to have. If you've created some sort of object, you have to label what the object represents. So we did that already. It's called a key. Right? So you have to have a key if there's a key necessary, and they're really obvious when they are. So a key is necessary in this one, and we have it. The other thing that we need on every graph is that we need a title for a graph. It needs to say what in the world this graph is representing. Okay? So the information given to us above can tell us what that is. It says the Automobile Club of America considers holiday weekends to start Friday, da-da-da-da. And then it says that these are the number of people who died, right? So what these are is these are the deaths on a holiday weekend. The title can go on the top. The title can go on the bottom. A title can be written to the side. It just has to be present. So put it wherever you'd like or wherever you have space. Okay, that good? That's one of our types of graphs, a picture graph. Dot or line plot. I'll call it a dot plot. It's written line in parentheses because occasionally you'll see other resources call it different things. But I'm going to call it a dot plot. This is a quick way to display data with fewer than 50 values. More than 50 values, we do something different. All right, so here's some data. The mass in kilograms of each child in Mrs. Good's class is as follows. So we have 40, 49, 43, all the way to 42, a bunch of random values, and we're going to make a dot plot. So here's what a dot plot looks like. You're going to draw a horizontal line, and on the horizontal line, we need to know what the smallest value is going to be on our line and what the largest. So what's the smallest data value you see above? 39? Okay. What's our largest? Is it 49? All right, so it's got to go from 39 to 49. Generally speaking, it's a small set of data, right? It's supposed to be fewer than 50 values. So you're going to make a hash mark for every single, like a tally mark for every single value. You're not going to skip any. So we're going to start with 39, and then 40, 41, 42. So a couple of things as I'm doing this. We want to make sure that our data looks like it's pretty evenly spread apart, right? Make it look reasonable. It's not going to probably be perfect, but that's okay. Something reasonable. 44, 45, 46, 47, 48, and 49. Okay? Now, the dot plot gets its name from the fact that we're about to put dots on it. But it's not the only way that we can do it, and it's hard for me to put dots on my screen up here too. So there's a couple other options you'll see sometimes. One of them is an X. That's the one I'm going to use, is little X's. You can also use like very small boxes. So if you were to do the boxes, you might do something where it looks like this to make a mark, you know. I'm going to use X's. It works a little bit better, and the book tends to use X's for this as well. So every single data value, we're going to make an X on this chart. And the X's will build on top of themselves when there's more than one. So we're going to go in order from left to right. So I'm going to do the 40 and the 42, like both of the top and the second one on the left first. So I've got 40. So I'm going to make an X here, and I've got 42. Whatever symbol you use, like my X's, they need to be about the same size, kind of like my hearts. And they need to be leveling at the same place, kind of like when I was talking about lining up my hearts, okay? So I have a 40 and a 42, and as I go, I'm going to mark them off of my table so that I make sure I don't forget anybody along the way or end up doing something twice. I have 49 and 41. So here's 49 and 41. 43 and 42, so 43, and then 42 actually has to be stacked because I already had a 42. That X is a little too big. Okay. What else did I have? Oops, there we go. 48 and 39. Here's 48 and 39. 46, 41. 46, 41 gets double stacked. 42 and 40. So 42's now got 3 of them on there, and the 40 has 2. 49, 45. 49's double stacked now, and there's 45. 39, 43. 39, 43. 47, 44. And then 49, 42. So this gives you a visual picture, right, of kind of how the weights in this case, or the masses, are distributed among the children in the classroom. You can see the minimum, you can see the maximum, you can see where things are bunching up, and so it's a nice visual. There is one more piece of information that we need to include. Do you know what it is? Title. Got to have a title. What is this information displaying?
The mass of each child.
Yeah. So it's mass, and we need to say in kilograms or it doesn't make sense, okay? So mass in kilograms of children, or you could say if each child would be fine too, children in Mrs. Goods class. Now, this one had a data value for every single one. You certainly could end up with some of them that didn't have an X on top of the little number. That would be an acceptable thing to see happen too. Okay, third one. Stem and leaf plot. This is actually one of my favorites. I really like stem and leaf plots. It works really well for grade distributions. So my example is going to be a grade distribution thing. Have you seen stem and leaf plots before? Some yeses and some nos. Okay. So these are akin, not akin, like it's not Dr. Akin, it's akin. They're like close to the dot plot, but they're drawn vertically so that the numbers on the left are called stems and the numbers on the right are called leaves. Okay, so as an example, like I mentioned, I'm going to do something with grades. This is actually like grades from an exam that I did like 12 years ago. It's the first set of data that I used in here, and I've just left it because it works just fine. There's no reason to change it. All right, so these are a first exam in a class that I had done. And we're going to do a stem and leaf plot for the data. So just like when we were doing the other one, we need to know what the smallest value and the largest value are. So you're first going to have to look for that. So what do you see? What's the smallest one? Smaller. Which one? 43, I think so. Okay, what's our largest value? 94? Okay. The stems are the tens places. So the smallest tens place is the number 40, right? And the biggest tens place is the number 90. So we're going to draw a vertical line to separate the stems from the leaves. And we're going to draw the tens places, those are our stems. So 4, 5, 6, 7, 8, and 9. Okay, so far so good. We're going to write out our stem and leaf plot twice. The first time it's going to be a little bit of a disorganized mess, but it's going to get it into the places where they need to go, and then we're going to structure it and make it look organized. Okay, so two-step process. So we're going to go through our data just like I went through our data on the other one at a time, and we're going to write the leaves in. For example, 87 is going to go on the row that the 8's on, right, because it's 87, and we're going to put a 7 on the right-hand side. That's 87. 76, same thing, a 6 after the 7. And I'm going to mark them off as I go. 94, 58, 82, 43, 89, 53, 67, and 80. 90 and 94. 74, 77. 87, 74. And then 89 and 90. So when I said it was disorganized, what I was referring to is the fact that there is no structured order in the leaves right now. I just got them into the right line. That's the goal. If you can do it in one step, that's great. I don't even try because I know I'm going to miss a piece of data, and then it's just going to be off anyway. So I just take it as a two-step process, and I think it works faster for me. So our actual answer, though, is going to take this and put the leaves in order as well. So we're going to redraw the 4 through 9. But then we're going to actually put the leaves in order. Now 43 is just the only one there, so that's fine. In the 50s, the 8 and the 3 are backwards. It should go 3 and then 8. And as I'm writing this table, I also want to make sure that things are lining up. So the first entry after the stem should all be in the same place, right? You should be able to go straight down just like with our hearts. The second one should all be in the same place. There shouldn't be numbers that look larger or more crunched together than others, stuff like that. The 60s, I have just one of them, 67. The 70s are, I have a 6, a 4, a 7, and 4. So there's two 4s, so I'll put them first. And then I have 6 and then 7. The 8s is the most busy, right? Because I have the most items in there. So the smallest value is a 0. And then I have a 2. Looks like there's 2 7s and 2 9s. In the 90s, I have 2 0s and then 2 4s. So the reason I like this so much for grades is because it gives you a very good visual of answering a lot of questions. How many students passed versus how many didn't? Which letter grade did I have the most of? We're going to talk when we get to section 10.4 about things like our mean, median, and mode. Those are probably things that you're familiar with. Median is just the middle value. I can easily find the middle value here. I can just count up. So if I count those people, I think there's 24 grades. Is that true? 18 grades? 18? Okay, so if I wanted to find the middle value, I could figure out where the 9th and the 10th grade are. So I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 are 80 and 82. The median is 81. It's halfway in between. So half the people in the class got higher than 81 and the other half got lower than 81. Right, so there's just so much I can just see really quickly with a stem and leaf plot. I do need one more thing though, a title. I do. So what would a title or could a title be for this particular graph? Okay, so they are first exam grades. And I actually need a key as well, especially because we're about to go see some other stuff with the stem and leaf plots pretty quick, where it's going to get a little more confusing. I need to know what it means. Like I described to you what it means. These are numbers on the tens place on the left, numbers in the ones place on the right. So you're going to take one that's unique, like 43 is a good one because I don't have a 34 on here. And I'm going to say something like this, where 4-3 is 43. And it'll make more sense why later to talk about how that's helpful. But the 4-3, like, please don't tell me, for example, I don't have one in this table. I'll have one later. 77, I do have one. 77. If you can't do, if that's not going to work, don't go 7-7 equals 77. Right? Then I don't know which is the tens and which is the ones, how they're corresponding. I know it looks like it should be obvious. It's left to right, but we're going to pretty quickly find something that's right to left, and that's going to make things complicated. Okay? All right. As promised, this is an extension of stem and leaf plots, and they're called back-to-back stem and leaf plots. Two stem and leaf plots combined to show the sets of data in comparison. One will have its leaves to the right, just like we just did, and the other leaves are going to go over to the left. So in between is going to be our stems, okay? So the data set that I just created, I'm going to go back and copy it because I'm going to need it in a minute. I don't need the whole thing, I just need the data set. Let's try that again. So I'm going to need it over here eventually. So I'm going to paste it, and I'm going to shrink it so that it's here, but it's not causing me a lot of space. Okay, so I'll use that as a reference in a little bit. Did everybody get that slide previous written down? Are we good? Yeah? Okay. All right, so this is grades from a second exam, all right? And we need to record the second exam grades much like I already recorded the first exam grades. Now, when I draw this in a moment, it's going to make more sense if I have the first exam on the left and the second exam on the right. So as I draw the stem and leaf plot that would be just for the second exam grades, it's going to look exactly the same as it would inside of the back-to-back one as it would by itself. So we're going to just draw this as a stem and leaf plot just like we have been doing already, and then we're going to merge these two stem and leaf plots together. So I need to know the smallest value, the largest value. So looking at the data, what do you see? Which one? 64, is that our smallest? And 99. Is that all right? Okay, so I have data that actually starts at 6, not at 4 like last time. Oh, not 5, 6, 7, 8, and 9 are the only values in the stem and leaf plot that I'm making just for the second exam. By the way, this is actually really data from the same class second exam. Scores are much better. You'll see that really quickly. There's already no 40s and 50s. That's good news, right? All right, so we're going to put all the data in there, and then we're going to structure and put it in order. So I have 93 and 96 to start with. I have 98 and 66. 67, 82. 92, 85. 64, 81, 86, 72, 96, 95, 99, 95, and 94, 74. Notice the first time that I do this, I don't have to pay any attention to making sure things line up, they're the right size, and it actually feels very much like, if you look at it, like I've done something wrong, because there are things that are not lining up. For example, do you see how my 2 and my 5 in my row 8 lines up to 3 numbers in the bottom row. That's not a good visual representation. I'm not done with it, so it's okay. But just be aware that if your final graph looks like that, that's not going to work. So what we need next is we need to do the stem and leaf plot that's going to have both of these data sets on them. So I'm going to draw 2 vertical lines, and I need all the stems of both graphs, which means it's going to go from 4 to 9 like the first one did, even though the second one only needs 6 to 9. So 4, 5, 6, 7, 8, and 9. Okay. The stem and leaf plot that I just created, I'm going to do this one on the right-hand side because it would go in order from left to right, from first to second kind of thing. But I want to get them in order. So right now I have 6, 4, 7, 4, so I want to make it 4, 6, 7. So this would be 4, 6, 7. My 70s, the 2 and the 4 are already in order. The 80s, I would have 1, 2, 5, 6. And then I got a lot of 90s. I have 2, 3, 4. All right, let's see here, 2, 3, and 4. 5, 2 6s, I think. What was there, 2 5s? Did I miss it? Sure enough, thank you. 2 5s, 2 6s. And then an 8. Did I get them all? And there's a 9. I think I marked the 9 out accident when I was trying to mark out a 6. I was like, I felt like I marked something wrong. Okay, cool. Okay, so this is our stem and leaf plot without, if I didn't have the vertical bar on the left-hand side, it would be actually the stem and leaf plot for the data right there, right? But what we're going to do now is we're going to take that first stem and leaf plot that's tiny up at the top, and we're going to reverse the data. We're going to flip it around, and it's going to go out from the middle on the other side. So what do I mean by that? Well, the 3 is an obvious one. So it's 43, but it goes like this, right? 4 and then 3 to the left. And then I have 30, I have a 3 and then I have an 8, but they're going to go 3 and 8 out from the center. So they flip. Before it said 3, 8, now it says 8, 3. And then I had a 7 for 67. I have a 4, a 4, a 6, a 7. I have a 0, a 2, 7, 7, 8, and 9. And then I have 0, 0, 4, and 4.
On the in row 8,
Yep.
I think it's 2 9s now, and 8.
Oh, is it 2 9s? Just copying down something that has a typo in it. There you go. So this one should say 9. Is that right, Emily? Thank you. Yep, I agree. Did I have a typo in it here? Or did I have a typo on 2 of my screens?
I don't think you had a typo, I just think you were doing it and it was like
No,
7, 7.
yeah, you're fine. I do have something wrong in my notes, but that's fine. I just want to make sure I didn't have it wrong in the notes that I'd given you, so that's good. All right, we're good. All right, so what do I need? A title. So what is the title going to be for this thing? Kind of out of space.
First and second exam grades.
That sounds great. So don't go overthinking this title business. Just describe what it is, okay? So yeah, this is the first and second exam grades. So I kind of want to take something that has a number on the left and on the right. So I'm just going to go to the first place that happens, which is this row with the 60s. Okay? So it has a 7 on the left, a 6 in the middle, and a 4 on the right. And I'm going to write down what this means. I have a 7 on the left, 6 in the middle, 4 on the right. So this means, so I should say where, so my grammar makes sense, where this means 67 on exam 1 and 64 on exam 2. Sorry, all this is running into things because I'm running out of space. But this is my description. So do you see what I mean about the necessity of writing these pieces out? Those vertical lines changed things. Some of them moved to the left and some of them moved to the right to give me an exam value now. So I have a 67 on exam 1, 64 on exam 2. All right. Moving away from stem and leaf plots. The next one we're going to look at is called a grouped frequency table. So what typically happens with group frequency tables is it's sort of an intermediate step to doing something else. But it's a standalone graph of its own accord, too. It just is often not where we're actually stopping with our data. So this one shows how many times data occurs in a range of classes or intervals. So everything we have done so far has preserved the values that we've been given, right? Every value that we were given, you can see it here. We're about to make them not preserved. That's what a group frequency table is going to do. It's going to group things together and you're no longer going to see individual values. Okay, so we're going to create categories. And grades is another one that we do this with so continually that I'm going to do it with grades. But it doesn't have to be done with grades. It could be grouping other things together too. So group frequency tables could be grouping together people's favorite, number of people in the favorite color they have, something like that, right? So think about little ones, right? Everybody whose favorite color is orange, go stand in that corner, right? And then you're making groups and things like that. So it doesn't have to be with grades, but this is a nice one. So we're going to keep using the same data set so we don't have to recreate everything. So this is the data from that second exam, the second one we did. And we're going to use the standard grading scale, okay? So standard grading scale is, right, 90 to 100 is an A, 89 to 90 is a B. That's what we're talking about for a standard grading scale. And we're going to group these together. So the way that this looks is that you actually draw kind of like a tally chart. So we're going to make a couple of vertical lines. On the left, we're going to describe the category we're talking about, which we are doing on this one, grades. So if you were doing the other example that I gave, you could write the word color there, right, or something like that. You could group together heights of students or the masses of the students that I gave in the example with Mrs. Good's class. So we've got grades. In the middle, you've got what's called a tally column, and it's literally going to be tallies. And then on the right, you've got a frequency column. And frequency is just the value, like the numerical value associated with the number of tallies. Like you count them up and you write down 7 instead of writing 7 tally marks. So we've said that we're going to use their standard grading scale, and we need to look, we know because we've already done it, but what's our smallest value here? 64, and the largest? 99, okay? So we don't need to do like a category for like the 50s or something like that. 60-something is our lowest score. So our grades are going to be in these categories of 60 to 69, and 70 to 79, and 80 to 89. And technically, it really should say 90 to 99. They should all be equal in value length. We know that we have scores of 100, so if you wrote 90 to 100, it would be okay here. It would make sense. But they really are supposed to be equal widths, right? These are called classes, and the classes should be equal in width. These widths are 10, by the way. It's not 9. Sometimes I have students look at it and think this is a width of 9. There are 10 grades in here. If you start at 60 and you end at 69, those are 10 different grade values there. Okay, so these are class widths of 10. We just get 100 thrown in, for the 11th one because it's there. So we're going to make tallies. So we're going to go through our data set, and we're just going to make a tally for each value and where it goes. So I have 93 and 96, which puts 2 tallies in the 90s column. 98 and 66. 67 and 82. 92 and 85. 64 and 81. 86 and 72. 90, whoa, sorry, hit the wrong button. 96, 95. And you're welcome to hash mark them over like when you get to 5s. 96, 95 there. 99, 95. 94, 74. And frequency just means you're going to count what's the tally column and you write the number that goes with it, right? So the first one's a 3. And then we have 2. And then we have 4 and 9, right? So it's just counting. And then we need a title. Okay, so I know you're going to get really annoyed with me asking that every time, but I'm hoping that I'm sort of forming your inner question so that when you do this, you'll remember it. That's the goal. That's what I do with my children when I work with them at homework, too. I ask them the same questions over and over and over again, and it irritates the snot out of them. But I'm hoping when they get to that test, that inner voice has become their own. That's what I'm hoping. So we need a title. All right, so what could be our title here? Yeah, grades on which one, Faith? Yeah, these are grades on a second exam. We don't need a key. This is a very straightforward picture graph. I mean, like, there's really nothing that we need to do other than that. Just the title is fine. Okay, I think we have time for a histogram, and then we'll stop for today. Okay, so a histogram is sometimes mislabeled as a bar graph. We are going to do something next time that's called a bar graph, and it is different. There are some distinctions about them. But this is a histogram that we're going to do today, okay? Histogram is made up of adjoining rectangles or bars. The categories are shown along the horizontal axis, and the frequency is along the vertical axis. Okay, so we're going to stick with our same information we had before. In fact, I'm going to copy this again and shrink it over here because we're going to use it. Oh, I didn't mean to copy those little hash marks. That's a little annoying. We'll erase those. Better. Okay, so here's a histogram. So we're going to draw a vertical line and a horizontal line. It said that along the horizontal line is our categories. So our categories are 60 to 69. So I'm going to label the 60, and I'm going to choose to label the 70. I don't need to label 60 and 69. That doesn't really make any sense. It's going to look like it's a continuum of values. Histograms don't skip any values, and there's no breaks between them, okay? So 60, 70, 80, 90, and I am going to put the 100 on there because that would be the sets of 10 apart, okay? I don't know why I've made it so tiny. I'll make it a little bit bigger. Now it's crooked. I think that's good. All right, the vertical is the frequencies. So we need either, you can do one of two things. You can put a hash mark for each frequency because these are not big values, right? I mean, it was really just up to 9. So we could totally do a hash mark for each frequency. If you had something that had a larger frequency, like maybe you were having frequencies up to 20, you might not want to label every hash mark. So you might make the hash marks like this, but you might only label like every other one. So just for the sake of you seeing that that's possible, I'm going to do that on this one, not because it's really that necessary, but that way you have a reference for it when you go back with a bigger data set. Okay, so there I labeled my 9 in there at the end, but so you don't have to label every single hash mark, but they need to be able to be seen that they're there if they're not labeled. And what we're going to do is we're going to take the information from our frequency table and we're going to put them as bars in this histogram. So the first one, the 60s, had 3 people in it, right? There's 3 people. So we're going to create a bar that has height. I'm going to do it like this. I think we'll try it. Height 3. Nope, I want it to be thin. So a bar of height 3. It starts at 60, ends at 70, height of 3. Now all my bars should be approximately equal width, and that should work out if I've made the hash marks approximately equal on the bottom. Okay, again, this is not a stressing issue. Just try to make it look pretty reasonable. How many did we have in the 70s category? 2. So I only need a height of 2 for that one. How about the 80s? Okay, so I need a bar of height 4. And what about the 90s? I clearly made the test too easy. That's what this is saying, right? It's a lot of A's. All right, so we have 9. All right, we're going to go from the 90. Oops, that didn't work very well. Still not working very well. Okay, I like that, okay. Bar of height 9. And it's perfectly reasonable to shade those in. If you don't shade them in, it's not a big deal. But we're going to see what are called double bar graphs later. And there will be a reason to shade them in. So if you wanted to shade them in, you could. And when we get to the test day for this one and stuff, I'll bring markers if you want to shade your stuff in, especially for the other example. But these are my bars. Notice they touch. Make yourself a note. Histograms have touch and bars. There's no space between them. That's going to be a distinguishing piece between them and bar graphs later. And what else do I need? A title. What might my title be? Grades on an exam 2 or grades on the second exam, right? Just like it was before. Okay, we're going to stop there.